So welcome, welcome. This is the STEAMSPort Robotics and STEM workshop sponsored by Black in Robotics. I am Carlotta A, and I'm a professor of electrical and computer engineering in the Lawrence J. Giacalotto Endowed Chair of ECE at Rose-Hulman Institute of Technology. This is in Terre Haute, Indiana. A lot of people have never heard of it, but it's about an hour west of Indianapolis, right in between Indianapolis and St. Louis. So we're going to do several things today, and we're going to wrap up with me giving you the details that you need in order to build an Arduino robot. A breadboard is a device that is used to build circuits in a neat and orderly way. And it gets its name, the formal name is a prototype or protoboard, but everyone just calls it a breadboard because people originally built circuits on a breadboard. So here's an example of one. It's a battery, a switch, an LED or a light emitting diode, it's like a light bulb, and a resistor. So the most basic type of electronic is the light, the LED. We call it the hello world of electronics. So if you ever learn to program, the first thing they always teach you to do is to print hello world to the screen. So in electronics, the first thing you're always taught to do is to make a light turn on. And people used to build them on breadboards with thumbtacks and wire. So that's how I got its name. Although now we use breadboards like this. So please find the breadboard in your kit and make sure you know where that is, because eventually we are going to use it today to build something. So a breadboard now looks like this, and it has things we call nodes. A node is the meeting point of circuit elements. So what that means is based upon the numbers and the colors, it tells me how things are connected. If you ripped it open, you would find these metal tabs inside. These metal tabs show the connection points because metal conducts electricity, okay? So what happens is anything I want to touch that is power, I put on this red column. Anything I want to touch that is ground or cold, I put on this blue column. We like to say voltage is hot, so it's red. Blue, ground, is cold, so it's blue. So the red and blue are called power rails. You got to have power to turn anything on. Just like you need power to turn a TV on, you need power to turn your robot on, you need the power for your electronics. In the middle is where we build our electronic circuits. Things we want to supply with power, we put in the middle. So if I wanted to build one with my LED, I put it in the middle and I connect it to my power. We can get power from either our microcontroller, which we'll talk about in a minute, or a battery, which I believe there's a 9-volt battery probably in your kit.
Yes.
Yeah, because there's one in my kit. Okay. All right. Breadboard. Once again, if I don't get questions, I'm going to keep the train moving because we got a lot to do today. Choo choo. All right. So on the breadboard, like I said, the red and blue lines give you your power. The middle give you your connections for your electronics. Things that are, you have to remember, and even my college students sometimes don't get this the first time, so it's okay if it's not all clear the first time through, is that these columns are things that can connect the power. These rows are things that are connected. So if I want some things to touch, I put them all on the red line or all on the blue line. Or if I'm in the middle, and I want things to touch, I have to put them on the same row. So 1A through E are things that touch on that row. 1F through J would be things that touch on that row. And there is this big divide or ditch in the middle where things won't touch if they're connected even on the same row. Okay, like I said, this sometimes takes a little while to get because even college students struggle with that. I mean, I don't want to say college students, engineering college students, I'll say that. Okay. All right. So if I tell you we're building something, like these are all resistors or LEDs, and I want them to touch end to end is called series. End to end means head to tail. Then it looks like down here where I put 22 and 23 for one element. Then I put 21 and 23 for the next element. And then I would put 20 to 23. So basically, they all have to overlap at one number to touch end to end. That's called series. If you want your elements to be in parallel, which means they're all connected on the top and bottom, then you would put all of the top rows in 5, all of the tops in 5, and all of the bottoms in 6. That means they're touching on the top and the bottom. So this would be the head to tail arrangement, which we call series. And this would be like a side-by-side arrangement, which we call parallel. Okay, questions?
I do have a question.
Oh, yes, yes, yes.
So the parallel and the series, what are the different, like what's the difference in outcome for like something that's connected through parallel and something that's connected through series?
Good question. So if you connect things in parallel, they'll have the same voltage. So if I want to power a bunch of stuff so that it all turns on with the same voltage, let's say I use my 9-volt battery, everything in parallel with that gets 9 volts. If I connect things in series, they have the same current. So let's say I need all my LEDs to turn on, but LEDs will burn up with too much voltage. So I don't want to connect them all in parallel because if there's too much voltage, it'll burn out. But if I put them in series, they'll all have the same current, but their voltage will drop differently because different LEDs have a different rating. So they won't burn up, but they'll still turn on, right? So it's a matter of the device that you're going to use and how much voltage it can take and how much current it can take. Okay, because I need to give it enough power to turn on, but I want to give it so much that I damage it. Okay, so a lot of times assembling things are to make sure you're giving it the voltage or current that it needs and you're not damaging it so that it works. Okay, good question. I'm trying not to go too deep into some of this because I'm trying to give you exactly what you need and nothing more than this, like McDonald's and Burger King have it your way. So resistors, there are resistors in your kit. And the good news is the resistors in your kit are labeled. But I always like to go over this quickly because if you ever get to the point where you lose the labeling or the resistors fall out of the package, you have no idea what they are. You can always Google this on the internet, resistor color code as well to figure it out. But for example, if you have a 330 ohm resistor in your kit, then the colors tell you orange, orange, brown. That means 3 times 10 is 330 ohms. So the resistors in your kit, everybody should see if they can find some resistors in your kit. There ought to be some in there somewhere. They all have colors on them. Those colors tell you what size they are. All right. So we talked about that the LED is like a light bulb, right? It's like so the LED is in your kit. Everybody should find an LED in their kit. And LED is right here. Mine are in a little box. Yours may be in a different spot, but mine are in a little box like this. Yep. Those are LEDs. So when we get to that point, you're very good. When we get to that point, you're going to put one of those on your breadboard. Okay. So when we get there, you're going to put this on your breadboard, and our job is going to be to make it light up. That's going to be our first job today, to make that light up. Okay, everybody good? Type in the chat if you're not able to find any of this stuff. Tony, did you find yours?
The LEDs, yes.
Yes, okay. All right, so then what we do is the LED has a long leg and a short leg, and you want to put the long leg to voltage, and the short leg is going to go to ground through the resistor, and we're going to use that to turn on our LED today, okay? So here's what that basic electric circuit is going to look like. It's going to have a resistor, a battery, and an LED, but we're going to put ours on the breadboard. You could just connect it like this too. And then we're going to turn it on. This is for engineers, so don't even worry about that. What you think about is this picture here. Your battery can be a 9-volt battery, like I said, or it can be your microcontroller. So we're going to use our microcontroller to get the power from our computer to turn on our LEDs. Okay, are there any questions so far? Okay, let's keep going. The other thing you're going to learn about is a push button. A push button is like a switch. A push button is used to turn something on and off. To turn something on and off like a power button. So in your kit, you probably have this and this, and you have to put them together to make a push button. Actually, this is your joystick. Let me find it. This is a kind of push button too, though, but this may not be the one you want. Let me find the other push button.
It's the tiny little one, right?
Y'all have it's a switch. So what it does is it turns, let me turn the captions back on. I wish this would just remember and stay on. But so what it does is it closes and opens a circuit. So after we figure out how to turn the LED on, we can add a button so that when we press the button, it turns the light on, and when we let the button go, it turns it off. Think about like a light switch in your house. So that's what the push button will do. It closes and opens the circuit so that we can turn the LED on and off, okay? So what we're gonna put on the breadboard is something that looks like this, and then we're gonna use our microcontroller to make it turn it on and off. The other device I want you to find is called a potentiometer. A potentiometer is a variable resistor, and it depends. It could be blue. It depends. There's blue potentiometers, there's black potentiometers. Let me find mine. Unless one of you find it first.
Is this it?
Oh yeah. No, that's not it. That's a relay. Put that back. Yours is not blue. Sorry, it's not blue. It's silver. Hold on, I'm about to hold it up. It's silver. It looks like this big metal knob. It looks like a big metal knob. I don't know about now. I now want to show you a video of what it looks like when you put some of this stuff together, which is what you're going to eventually do with your kiddos. 1 second, because I want the sound to be on. So hold on. Where's my share button? Okay, so now we know what a breadboard is. My potentiometer is this blue box. So the thing you guys just went hunting for, here's mine. It just looks a little different. Here are the LEDs, here are my resistors, here are my wires. Okay, so this gives you an example of some of the projects you can do with the kids, right? So just by using those same 3 or 4 devices that I just had you pick out, you can do 5 or 6 projects. So that SparkFun Inventors Kit book that I had you download, these projects are in there. There's also another set of projects that come with the kit you got. They're not quite as explained as well, which is why I would suggest you start with that guide I had you download, because it gives color pictures and it goes step by step. The one thing that you guys may have to differentiate is some of their parts may look a little bit different than yours, like that potentiometer. okay? The one thing in the video that you saw that I didn't go over today, but you do have one in your kit, is right here. This is called a photoresistor. A photoresistor is a light sensor, okay? In your kit, you should have probably at least two, because I have them in my kit, two photoresistors. Yep, my Kiara is the finding queen. So they're in the box with the button. I'm sorry, they're in the bag with the button. They're in the same plastic bag with the button. And that's called a photoresistor. It's called a light sensor. So what you should have seen in the video is I would cover it with my hand to make something happen. So when you make it darker, so you can make a night light with that. It's called a photoresistor. So in your kit, they also describe ways that you can make night light by covering that and turning on the LED, okay? Any questions?
I like the Morse code. I was thinking about activities and stuff that we could do.
You also,
like,
not only do you have Morse code, but you also have an RFID device in your kit that you can use for sending secret messages to, where you can set that up and then the kids can program it to send a message that is hidden unless you look at the receiver. So because it's in mine, it's called an RFID device. If you think about it like at the grocery store kind of thing, things have like the barcodes on it. You know, you have to scan it to see what the barcode is saying. There's an RFID in your kit too that can be used for sending messages. But if you want to teach the kids Morse code, you can do that one where they have to actually just look at the lights and figure out what the message is too.
Okay.
Okay, let's keep going. So in Tinkercad, if we're going to build something in Tinkercad, what we're going to do is you put out a breadboard just like a real one, and we could turn on a battery to put on a battery, a resistor, the LED, and a button, and we can make a blink. So we're about to do this in a minute, but I want to show you the video first. We're going to do two Tinkercad activities, one with just the battery, one with the Arduino, and then we're going to go to your actual physical kit, okay? So this is what this looks like. I've wired it up. There's my button. And because I've given it a voltage, when I press that button, it turns on my light. I can do this in Tinkercad, and then I can go do it in my physical circuit as well, right? So this is what we're going to do. Then the next activity we're going to do in Tinkercad is, hold on, my internet's acting up. Okay. Here, let's just do this first. I'll show you this first. So here's one where you now put that's your potentiometer, that's your knob, and this is making a dimmer, like Tony said earlier. So now instead of me using the button and pressing the button to make the light turn on and off, I add the dimmer, and the dimmer makes it get dimmer and brighter. Does that make sense? So I'm now going to share my screen, and we're going to go to Tinkercad and do these two activities. Okay, so everybody go to tinkercad.com. See it now? I'm sorry. I thought you guys could still see my screen. I'm so sorry.
So should we have it way down at the bottom like yours is, or does it matter?
Nope, they're all connected. So Tony, this is also correct, although people don't normally do that, but you normally don't do that because that's taking away some of the breadboard you could use. But anywhere on this red and blue line or red and black line is fine. I'm so sorry. I thought y'all could see what I was doing. I apologize. Okay. Thumbs up when you're there. Okay. So now I need to put my my LED on my circuit. So what I'm going to do is one leg is negative and one leg is positive. So I'm going to click on that LED and I'm going to press R 1, 2, 3 times. Click on the LED and press R 3 times. Okay. Now we're going to put that on our breadboard, and it does, as long as they're in different rows, it doesn't matter, but I'll give you my numbers. My numbers are going to be E14 and E15. I put my LED at E14 and E15. I'm going to zoom in a little bit so you can see. I put my LED at E14 and E15.
And you said it does not
It
have to
doesn't
be.
matter as long as each leg is on a different number. You cannot have them on the same number, but I could put it at E8 and E9. I could put it at E20 and E21. It doesn't matter as long as each leg is on a different number.
Does it? What would happen if you put it actually on the rail?
Nothing. You mean like if you put it right here?
On the, okay, hold on. Let me talk about it. On that plus and minus.
Oh, you don't want to do that either.
Okay.
So what would happen is if both legs are in red or well, both legs are in black, the LED won't turn on and you won't hurt anything. If you put one leg in the red and one leg in the black, in fact, let's do it here because here you can't hurt anything. If you did this on your real thing, you would burn up the LED and it would stop working pretty soon.
Okay.
If I do it on here, what it does is it shows you that you're going to break it. So if you give it a minute and I start the simulation, it'll light up for a second and then that shows you just blew up your LED.
Would it matter if, I mean, just like in this line, so you did it on the correct way, you just did it in this particular row where you have your battery connected, would that make any difference?
So, well, okay. So if I do that way, I burn up the LED because I want you to see what happens. So I burned it up by doing it that way. If I do it this way, nothing's going to happen because it's wired incorrectly. It won't turn on. It won't do anything because it's not wired correctly. Same thing if I do this.
Oh, okay.
Nothing's going to happen because it's wired incorrectly.
Okay.
Right? So all those other ways, it won't work. And if you do it that one way I showed you, you're going to burn up your LED.
Okay, gotcha.
Okay. So the way that we keep from burning up the LED is we put a resistor in series with it. This resistor is too big. Too big. So my Kiara asked us earlier, if I put this resistor in, the LED won't turn on because it drops too much voltage. So click on your LED. I'm sorry, click on your resistor. Click on your resistor. Look over here where it says 1K, this is ohms. You're going to change it to the ohm. So click the drop down and make that an ohm, omega. It's an omega for the Q dogs in the house, but it's really an ohm. It's a Greek letter, omega. All right. And we're going to change our resistance to be 330 ohms. Okay. So click on the resistor, change from the drop down from K ohms to ohms, which is an omega, and then change the value to 330. Thumbs up when everyone's done that.
I may be running slow, like I'm clicking on my resistor and it's not.
You don't see a window popping up on the right that says resistor? It's a blue box.
It was, but it's not anymore.
Click on the resistor again.
Yeah,
Did it come back?
Nah, and it may be just me because I don't want to slow down the class.
It may be hidden. If you zoomed in on your screen, it may be hidden off to the right. You might need to zoom out a little. It should be on the right side where all those parts were. It may have disappeared, but you got to click on the resistor for it to show up. Like if I click off the resistor, it'll go away.
Yeah, that's what it is. When I click on the resistor, it's highlighting, but that box, it was popping up. It's just not. But go ahead. Okay,
keep trying to get that 330 on. While you're doing that, I need everybody else to press R on their resistor 1, 2, 3 times to make it horizontal. Click on the resistor and press R 3 times to make it horizontal. Okay, thumbs up when you're ready. Okay. William, you find that box because this is bothering me.
Okay, I just refreshed and see if I can.
All right. While you're doing that, I want everybody else to slide their resistor from B15 to the black line. Slide your resistor so it's between B, as in Bob, 15 to the black line.
And Dr. Barry, you said, because it popped up now, you said my resistance needs to be on
330. So change that 1 to 330. Mm-hmm. Change that drop down that says K ohms so that it just has an ohm or an omega by itself. Okay. Then you're going to click on the resistor 3 times
Mhm.
with the R, click the R 3 times to make it horizontal, and slide it over to B15 to the black line, B15 to the black line. Okay, thumbs up if everybody has that. Okay.
Now, question for you. How did you, is this something that you just knew in terms of the resistance and then the, whether it's the K or the
Well,
N?
yes, I'm an electrical engineer, but I will tell you that that book I had you guys download, that Spark Fun Inventors Kit guide, the SICK guidebook that I wanted you to have everybody download in advance,
Mhm.
it walks you through this. What I'm telling you is step by step explained in that book.
Okay, gotcha.
But then, yes, I also teach this, so I know it. Like I teach this to college students too. You gotta remember, I do this all day. So it just lives in my head. Okay, so now we have our negative power connected to our LED. We need to connect our positive power. So if I click here with my mouse, I can make a wire. There's wires in your kit, but I'm drawing you a wire here. And you're gonna make that wire connect the red line. I'll change mine to red because normally red is power, and to make it easier for you to see, you're gonna draw a wire and connect it to the red line. In your kit, you have lots of wires, right? So when you're doing this with your kids, you use these actual wires that are in your kit. You have lots of types of wires in your kit. I'm holding them up to the camera so hopefully you can see that. But so what I just drew are these wires that you would use to connect things in your kit. Okay, thumbs up when everybody is there. Jarvis, J Boogie. Okay, press start simulation, please. Press start simulation. Did your LED turn on?
Yes.
Yes.
Okay. Mike here, your LED did not turn on. Make
No.
sure that everything is in the right holes, and if any of the holes is even a little bit off, it won't work, right?
Oh, I think my resistor's in the wrong place.
Yeah, make sure they're all in the correct row. If they're even off one row, it
Yeah.
won't work. Is it on now?
Yeah.
Tony, did your LED turn on?
I'm doing it now.
Okay,
No.
okay. Make sure everything's in the right holes. The resistor should be in B15 to the black line. And the wire is in, I think that's C15 to the red line. C15 to the red line.
You said C16 to the red line.
C16, yes, sorry, C16 to the red line.
Okay. Does it matter which one the resistor is in?
It does. The resistor
I'm
needs
sorry.
to be,
No.
the
Yeah.
resistor needs to be in B15 to the black line.
Okay, I'm
B15.
sorry. Not the resistor, the LED.
Yes, it matters. So the LED needs to be in D15
In D. Okay,
and D16.
I don't have it in D.
Yep, the rows matter. Remember we talked about that series and parallel thing? If they're not touching, it won't turn on.
And you said the resistor was what? It was D.
The resistor is B as in Bob, 15 to the
Okay.
black line.
Okay, that's in the right one.
Okay,
I
and the
think it's my
Y
LED.
and the LED is in E as in Edward,
Uh-huh.
15 to E as in Edward, 16.
I'm not getting it to move.
I may have to have you share your screen.
I'm
Okay,
on a different computer.
you think it's okay or you don't think it's okay?
I'm not getting my LED moved.
If you click
May
on
have to
it,
refresh. Like I had to do the same thing. I had to refresh
yeah,
my
that may
screen.
be an internet thing because it should just
Okay.
move.
Okay.
Now, if you refresh, are you gonna lose all your work?
No, it didn't lose it. Like when I couldn't get
Mhm.
the resistor, the
Okay, now I got it. Okay, the LED has to be in, what was the row again?
E, Edward,
Uh-huh.
15,
Okay.
and E is in Edward, 16.
Okay.
Okay, and then if you push start simulation,
Yes.
does it turn on? Yay!
Okay. Yeah, the LED was in the wrong one. Okay.
What we doing, William? Okay, so now, all right, click on the button. Click on the button, your push button. Click on your push button. Sorry, your push button. And click R 1, 2, 3 times. So that it's now horizontal. And we're going to put it on this ditch. You're going to put it on both sides of your ditch. So that means you're going to have one leg in Edward 18, one leg in Edward 20, one leg in Frank 18, and one leg in Frank 20. Click on your push button, click R 3 times to make it horizontal. And now you're going to put it so that it rides the ditch. And you're going to put one leg in E18, one leg in E20, one leg in F18, and one leg in F20. Okay. All right. So now you're going to take this red wire that was going to the red, and you're going to bring it up to C18. Take the end of the wire that was going to the red and bring it up to C18.
Oh man. What if yours is green? Like mine is.
Oh, it doesn't matter. The color doesn't matter. I color code my wires so that you know if they're voltage or signal or ground or hot, but the color doesn't really matter. It can be whatever color you want. Green is the default color, actually.
So okay.
If you want to change the color, it's at the top, William. It's right here. At the very top, it's a square with a color on it.
My wires are going haywire. I can't. So I'm trying to figure out how to, because I'm disconnecting it from where it was originally.
Then put it at C18.
How do you get it to disconnect? Mine continues.
Oh, okay. Just click on it and delete it and make a new wire. Just click the wire and click delete and make a brand new one.
Gotcha. Okay.
If it won't work, just click on it and hit delete.
Damn, I just the whole grid.
Control Z, William, to bring it back.
Okay.
Okay. Then you're going to make another wire that goes from C20 to the red line. Make another wire that goes from C20 to the red line. And I'm going to ask you guys what you think I just did. Mike, Kiera?
You made a circuit. Is that a series? And then
I made a series circuit so that now instead of it going directly to voltage, it has to go through the push button to voltage. So that means unless I press my button, the LED is not going to turn on. So I want you to run this and see what happens. So hit start simulation and see what happens when you press the button and when you don't press the button.
So you just click on the button to press it, right?
Yes, you do. So do start simulation and see what happens if you press the button or if you don't press the button.
So I have,
yes, go ahead, Mike here.
So the power, for lack of better words, how is it getting from, like, for instance, how is it getting from the LED light to the wire to the button if it's not like directly connected?
Okay, so metal is a conductor, metal. So this is why you don't ever want to be near electricity with metal, because current flows through metal and your body has resistance. You could actually electrocute yourself. That wire has metal in it. The breadboard has metal in it. So anything that's touching metal, current is going to flow through it. So where the current is flowing is starting at the red on my battery. It's flowing through that red wire to my button. There's a break in the button, so nothing happens unless I press it. Then the current flows through this wire to my LED. It goes to the electronics in the LED to turn it on, and then it flows to ground. Current always wants to flow from higher voltage, higher potential, down to ground. So it's flowing through all my devices, through the metal in all these devices to get to the ground. Got it?
And that's why the breaker board is important. Okay.
That's right. That's why the breadboard is important, but you can call it a
Breadboard. I'm so
all
sorry.
right, so if I start my simulation and I press the button, it turns on. I'm getting an exclamation point. I think that may mean the voltage is still a little high, but it doesn't really matter because it's not burning up, right? Because we know what burned up LEDs look like. It looks broken. So, all right, are we good on that?
Yeah.
All right, I'm going to do a couple more things on here. I still want to get us to the kit. So now I'm going to take this off. So I'm going to stop this. I'm going to delete the button. Delete the button. And I'm going to delete the wires. And I'm going to move my LED. I'm going to move it down to 19 to 20. So all I got on there now is the battery, the resistor, and the LED.
$19 and $20 or $20 and $21?
Either one is fine.
Okay.
Do 19 and 20 because that'll be consistent with where mine is.
Okay.
Do E19 and E20 to be consistent with where mine is. All right, so now what we're gonna do is we're gonna add your potentiometer to make a dimmer, So you click on it and the blue window should open up. The blue window should open up. Okay. William, hopefully your blue window showed up this time.
Yeah.
Okay. Change K ohms to ohms. And I'm just going to put 100 here, okay? Because it needs to be something small. So make sure it's your potentiometer should now say 100 ohms, 100 ohms. Thumbs up when you have 100 ohms. Okay. Okay, now we're going to click the potentiometer and click the R 3 times. 1, 2, 3. And you're going to put the potentiometer at E14, E15, and E16. E14, E15, and E16.
So the center pin is lined up with the resistor?
Correct, sir. So that means that center pin is touching the resistor. They are in series. Okay. Thumbs up when everyone's there. Okay. Tony and Elliot, okay? Okay. Now you're going to make a wire from David 16 to David 19. Make a wire from David 16 to David 19. Okay. A wire from David 16 to David 19. And a wire from David 20 to the red line. And another wire from David 20 to the red line.
So if you were to color code these wires, would you put them as different colors or would they be the same?
I would, and there are standards in engineering, which I haven't told you, but normally cold would be like black, green, brown. Voltage would be like orange, yellow, hot colors. Signals, which we haven't talked about yet because we're not at the microcontroller, would be like white, yellow, blue. But for kids, just let them use whatever color they want, just as long as they're learning this, right? They can do all that stuff later. But yes, I do color code things to help people understand, and they can match and say, does your blue line match my blue line? Does your red line match my red line? So that's something you can do with kids to help them follow the wiring, right? Is everybody there? Start simulation and see what happens. If your LED turn on,
Yes,
what happens if you turn the knob?
it's staying the same though.
Is it?
Yeah.
Does it get dimmer?
It's not changing.
Yeah, man.
Okay, we may need to make a smaller resistance. Okay, stop your simulation and click on your resistor. Stop the simulation and click on your resistor.
Okay.
And let's make it something smaller. So we made the potentiometer 100. So let's make this. Ooh, I know what's wrong. Bad professor. No, I know what's wrong. Never mind. Don't do anything to the resistor. I want you to delete the wire between D16 and D19.
Okay.
And I want you to make a wire from Edward 16 to the red line. Edward 16 to the red line. So once again, William, this is just electronics, okay? So this is not something you guys would have to do. The book would show you how to do this. Okay, so make a red wire from Edward 16 to the red line and let me know when you're done with that. Okay, now make a wire from Kathy 15. I'm really loving making up these names, can you tell? Make a wire from Kathy 15 to Kathy 19.
I'm sorry, for the previous one, you said Edward? I thought you meant.
I'm sorry, Alpha 16 to the red line. Tony be getting me. You're right, Alpha 16 to the red line. Alpha 16 to the red line. And then you're gonna make one from Kathy 15 to Kathy 19. Kathy 15 to Kathy 19. Now try it again and see if it dims and brightens. Sorry, I had the wiring wrong.
Yeah, it does.
Yep.
So what we did there is we made something that's called a voltage divider. And a voltage divider basically changes how much voltage is getting to your LED by the value of the resistor. And I'm changing the value of the resistor by turning that potentiometer. So that's why it's getting dimmer and brighter, because thinking about what Mike Kiera asked earlier, it's getting less current or less voltage. They're in series, but when I change the resistor, more voltage is dropping across the LED and I'm making a dimmer. All right. We're now going to do this with the microcontroller. So I'm going to stop sharing this for a minute and go back to my slides.